Okay, so module 2 has a second part which is theory of torsion. So torsion is related to torque. Okay, torque is basically the ability to turn or rotate something. Okay, rotate an object within an equilibrium or within an elastic limit. Okay, so every formula we have seen through module 1, we always talk about elastic limit. Okay, because every formula we will be work only and only if the whole thing within elastic limit. Okay, if it's a bend or permanently damage, permanently rotate something, then it will be not useful. Means this formula will be failed. Okay, this formula work only at that point up to its elastic limits. Means if theta, suppose we consider that theta is angle of twist, when it's twisting, the bar is twisting like means some degree. Okay, but afterwards it needs to regain its original shape. Okay? It is elasticity, right? So it needs to regain its original shape. That will be the formula. All the formulas will be work. But if it's not regain its original shape, then it will be fail. Okay? So here is T. We have taken. Consider a bar first. Consider a bar. What cylindrical bar, and it has a diameter, right? Diameter. So we will be taken as the highest radius, means outer side radius, which is R. R is radius. We will be take it in mm. Okay. Then theta will be a degree or radian we can measure. Angle of twist, here you can say. Why I am explaining this means when you read a problem, you will get there the written statements like angle of twist or length of bar, shear stress, etc., etc. So you have to convert it into your given parameters. Okay, so polar moment of inertia is Jp. Okay, torque is T. You have to look on that unit also carefully, because this unit will be what important, very important role in that problem solving. Okay, so here is T by Jp. This is torsional formula. Only one formula in that full torsion topic. So you have to by heart this, and this is very easy formula. T by Jp is equal to G theta upon L. G means shear modulus. Okay, modulus of rigidity tensor also. Theta will be angle of twist. L will be mm. If L is we taken in mm, then theta will take will be in radian. Okay. Then G will be, if L is in mm, then G will be in Newton per mm square. Okay. G, shear modulus. If G is in Newton per mm square, also tau means shear stress. Shear stress will be in Newton per mm square. R is radius, also it will be in mm. Okay. Jp has two formulas, means somewhere shaft will be this rectangular bar will be a solid, and somewhere are the hollow shaft you can have. So the Jp for solid is pi into d square, d raised to 4, pi by 32, d raised to 4, pi by 32. Most of the time we have written that d for solid is in capital, so it will be easy to understand. Okay, and pi by 32 for hollow is d raised to 4 minus small d raised to 4. It will be easy to understand. Okay, you can take this as well. Okay, no problem. Then T is torque. Okay, T is torque. T can be easily found by this fourth formula, 2 pi nt by 60. Okay, but here look carefully. Here is power in watt. Okay, if power is given, you need to take it in as it is in watt. Okay, now don't use here is kilowatt or any other. Okay, only it will be taken in a watt. Then number of rotation means n is rpm, 2 pi 60 are a constant. N will be rpm, which is given. Okay, you can easily find the torque, or if torque is given, then you can easily find the power. Okay, so if after this, by using this formula, if you find a torque, then it will be a Newton meter only. Okay, it's not a Newton mm, it's only Newton meter, not per meter. Okay, it's Newton meter. If power in taking in watt, then torque will be find out in Newton meter. Keep it in mind. If torque is given in Newton meter, then power will be found by this formula. It will be in watt. Okay, don't mess with the unit. Then after that, you find a T. In here, you have to take T in Newton mm. Keep that in mind. Means if you are taking everything in mm, then JP has a formula where you are using D. So what is D? D means diameter, and it has a unit mm, right? But you have a equal formulas here. All us we have taken mm units, so we need to convert that T into Newton mm. So how can we convert it? It simply multiply by 10 raised to 3. Okay. Then torsional rigidity has a different formula. It's only theta and Jp will be exchanged with each other. T by Jp is equal to g theta upon L, our original formula. But torsional rigidity, if in example this will find out the torsional rigidity, you can simply find out Jp by L or T by theta. Okay, then polar modulus of section Jp by R. Okay, that's all. Then